I'm giving one question to you, all of you. That is like mm, xi, iid, normal, 0 theta. Okay, and theta greater than 0. Can anyone find wait, no, this is not the intended question. Wait, just a second. I am seeing the question. 1 second. Mm, so Prerna is in the class or not? No, she's not in the class. She's sending one question. She sent one question to me. That's a very good question. I am trying to give you that question so that you can understand that question. Wait. Um. Yeah. Prerna, just can you please send the question again so I can discuss this question here to all of the other students so that they can also get that problem too. In the group you can say it also, right? Because that was a good problem and also a new problem. Right. Yeah, thank you. So there are problem you can see in the group, right? So I am not writing that question number 50. So that was a good question because they asked about expectation x order 1 given t minus t expectation x order 1 by expected value of t equal to alpha beta. So what will be the value of alpha? So the very first work which will come in your mind, that is you first go to find expectation x order 1 because t is given here summation xi. But note that when you think about expectation x order 1, don't go to find that expectation x order 1 because think that wisely, xi is given gamma function, right? So if you want to go expectation x order 1, then you have to come over to the CDF, right? In the PDF there is a CDF term involved na, in the fx order 1, n into 1 minus fx whole to the power n minus 1 into small fx, but you cannot find capital fx. uh, you know you cannot find capital fx explicitly, right? So that's why you don't go on that way, you have to take another way. Okay, so it's the first idea which will uh, stuck on your mind, which should stuck on your mind. So don't go to find expectation x order 1 because that will take your time, because main target of the entrance exam was to take your time. Okay, because they know that you are a good student and all good students are give that exam, but not all good students get into the IIT and the ISI in that of the uh, greatest institutes and the premier institutes, because the main problem is that they did not get to the point. Okay, so we have to the point. So first in this problem, see what is the necessary thing. If you take expectation on it, then your work is done, right? I think Prerna also did into that trap, right? She go to find expectation x order one. So that's why this problem.
Yes, thinking like just some
Yeah.
sufficient statistic, is it or not?
Yes. Yes, yes, that is also an idea because I also when Prerna sent that question, after solving that question, some of my friend will give gate exam. So I sent that to there. So I told that please solve this question because that may be important for your gate preparation. Because I cracked the gate exam also then, so they just came to me for some suggestion that thing. So I gave that question there. So from them I gave a sample. From them I got a sample who are thinking about to find expectation x order one, and someone thinking about like you, that is a sufficient statistic, UMV, this type of concept stacking on their mind. But the first thing is that you should thought in that way. You cannot find expectation x order one. So you have to use the expectation totally. Then the total thing is a like a cheese. It is expectation x order 1 minus expectation x order 1, because if you take expectation on this thing, that will cut out na, right? So that is will be alpha beta. So alpha beta will be 0. Say one line question. Understood that line, that the step jump? I think understood, because you know that something you on don't understand this step, because when we take expectation on this thing, it is this. But note that this is a constant now, we cannot find it in our hand. But if we use R programming, then by simulation we take sample and we can find the minimum order statistic, and we can get the idea of expectation x order 1. So it is a constant part, right? So it will be expectation x order 1, right? So alpha beta 0, and it's a gamma function, a gamma distribution, so beta obviously greater than 0. So alpha equal to 0 as, right? Understood everyone? I am writing properly, that's how you can understood. Whoever do the class, they get the maximum মানে, maximum usefulness of the class, because by seeing the note, something maybe they not understood, because I am what I'm telling you, that the strategy of the exam to crack the exam, because you all have the concept, and in the competitive market, not only knowledge is enough, right? Okay, so this is the question, and we are that imply this thing equal to alpha bit, that imply this thing. I am taking just expectation and using the linearity law of expectation, right? Linearity law of, yeah, right. So I'm this is a good question, that's why I gave you this thing. Now I'm going to solve the next question. Have you all heard about the Basu's theorem? Everyone, anyone can say me what's yeah, Basu's theorem, you know, right? So do you know about the ancillary statistic?
Yes, Bhaiya.
Right. Do you know about the first order ancillary? Anyone? First order ancillary? So yeah. So right. So I'm writing a definition of first order ancillary. So the thing is that it will give a help to the solving problems, to solve problems. So first order ancillary is that if hx curl be a statistic, then let hx cal be a statistic, then expected value of hx cal equal to c মানে constant, that is expected value of hx cal is independent of the parameter, then it's called first order ancillary. So have you know about the concept about the ancillary statistic? I just give you idea what is ancillary statistic. So I'm not writing this, I am just telling you that thing so that your concept will be better for just your concept. That is, you know about the sufficient statistic now. So in sufficient statistic, the 100% information content into the on that statistic, right? And your work is to reduce the dimension or the the size of the data, because if it is a n size data, then it is very much impossible to handle that huge amount of data. So our target is to reduce, it's a data summarization process. Then we are coming to the minimal sufficiency, and in minimal sufficient statistic we actually reduce dimension of the data and summarize the data, and but the 100% information content into the sample, content into the statistic, right? It's the sufficiency principle. Now here is coming the completeness. So what is the completeness? The completeness is says that you know the definition, but what is the completeness actually say? The completeness basically gives a the accuracy to the sufficient statistic. Why? Because in the sufficient statistic there is some ancillary information happen, ancillary information into that statistic. Ancillary information means the garbage information, right? When you want to know the height of the population, but they also give you the weight of that population, that is in irrelevant na. So that is a ancillary type of information. So the complement of the ancillary information is the completeness. The complement of the ancillary is called the completeness, right? So when you find the complete statistic, that means there is no involvement of the uh, ancillarity or the garbage information, right? So this is the main concept, and I can give you an example where you can see that in a minimal sufficient statistic, uh, there is involvement of a ancillary statistic, but it cannot be happen now. You can think that it's a minimal sufficient statistic, and in the minimal sufficient statistic why the ancillarity will come, right? But the thing is that the complement of the ancillary statistic is the completeness. So when you find a complete statistic, your goal is complete statistic. The goal is that to remove the garbage information from the from your statistic. Then it is a good statistic, and you can say the best statistic in terms of this principle. So that's why complete statistic and the ancillary statistic is also always independent. So it is the main concept of the Basu's theorem. So I am giving you some example. So Basu's theorem I'm writing here. Acha, one more thing. Ancillary T imply first order ancillarity, right? And that means ancillarity means that statistic is independent. Sorry, the distribution of the statistic. Distribution of statistic is independent of parameter and that expected value. And obviously, but that distribution is independent of theta means you know that expectation is also independent of theta, and that first order. So it implies the first order ancillarity, but the converse may not be true, right? Basu's theorem said that whoever don't know for that I writing a complete statistic is independent of ancillary statistic, right? So I told you beforehand that I will discuss some concept also, because sometimes this concept can help you to understand the question, because in the meantime I'm seeing that some conceptual questions are also coming in the jam, because they are not like that you have to solve a problem rigorously. That type of things is not like jam, I think. Jam or gate, whatever, I think that some very conceptual and very tough problems are coming in the meantime on that exam, like I say. So in jam, particularly in the previous years, if I see that they just maximum of the questions is like to find something to the numerical type problem. That's now in MSQ they give some conceptual questions also. So that's why I am just discussing this thing. This is not like in the syllabus, but if you know, then you can find very easily the independence between two statistics, right? So it's not irrelevant. Okay, then I am giving some good example. Wait, mm, let me find the example. Right. Yeah. So the thing is that the ancillary statistic doesn't contain any information about theta. I'm writing this here. The statistic is independent of the parameter. So ancillary statistic doesn't contain any information about the parameter theta, right? So like xi follows iid uniform theta plus 1. So what will be the minimal sufficient statistic? Can anyone give me a quick answer? Sir, can you please repeat once that you said about minimal sufficient and ancillary? Okay. So minimal sufficient and ancillary. Okay. So see, first you have a class of all statistics, and where the sufficiency means that 100% information content on the statistic, right? And your target is to reduce the data. So if it is a dimension n, then your target to reduce that dimension n to a lower extent. Like it is a two-dimensional statistic, one-dimensional statistic, then your data is reduced, but the 100% information content on it, right? It is the definition of the sufficiency and minimal sufficiency. That the same thing. The minimal sufficient statistic is the function of every other sufficient statistic, right? Minimal sufficient statistic is the function of every other sufficient statistic, right? So then come over the ancillarity. So it's the concept. So that's why I coming to this section. So what is the necessity of the completeness? So that you know the completeness is like of the one function, right? So it is a function. Mane, completeness is that it is the complement of the ancillarity. Ancillary means the garbage information that's no use in your parameter of interest, right? If you want to estimate the average height of a population, then what is the usage of the average weight? So this data is irrelevant to you. So in the sufficient statistic or the minimal sufficient statistic, there may be there may have some ancillary information. That's why they do not complete. Like in this example, uniform theta theta plus 1, you know that in this um, for this example, for this family, you cannot get a complete statistic, right? You get x order 1 x order n is minimal sufficient statistic, right? You all know this thing. But you cannot you cannot achieve the completeness. Have you ever thought why we cannot achieve completeness for this example? And you, I think all of you know that if the dimension of the parameter is 1, then if the complete statistic exists, that will also one dimensional. Have all of you know it, or I am writing this concept? Hello, yes,
Uh,
Sai.
I didn't know this. Can you write? And also, if completeness doesn't exist for complete static doesn't exist for this example, then does it imply that UMV of this thing doesn't exist?
No, that is like for uniform, yeah. For uniform theta theta plus 1, expect x order 1 and x order n is minimal sufficient. X order 1 and x order n is minimal sufficient. So you cannot achieve the UMVU like thing.
So UMVUE for this thing doesn't exist.
Yeah, because UMVU is obviously being function of the complete sufficient statistic.
Mm. Okay, and so we cannot say that only X order one is sufficient, right?
Wait, one second. Yeah. Only x order 1 is not sufficient because the it is depend on the theta in a indicator way. I am writing good
Okay.
in the good
Okay.
man. Hmm. UMVU ka definition doesn't say. No. In Levensev theorem, no, it just has to be a function of sufficient. No. In Levensev theorem, if you don't find a sufficient if you don't find a complete statistic, then how can you achieve the UMVU? So on that sense, UMVUE is based on completeness stuff. Yeah, UMVUE is based on complete sufficient stuff, right? So if you know about Levensev theorem, na? In Levensev theorem, it is expectation Hx given T. If T is complete sufficient, then has no complete stat. Yeah, what are you writing here? Uh based on completeness stuff. Yeah, it's based on completeness stuff. I think you were said about the Rao black hole theorem.
I'm only saying that if complete statistic doesn't exist for this distribution,
Hmm.
that means UMV doesn't exist, right?
Right, because you know the theorem that if you get a complete statistic and that is the unbiased estimator of some parametric function, that will be the UMVE. That will be unique, and unique means it's UMVE. Because UMVE if exists, this is the definition. Na UMVE if exists will be unique. So from minimal sufficient statistic we cannot achieve the UMVE. Yeah, Sanjay, please.
I problem in finding the uniform minimum variance and was just most of the question. Can you give an idea?
Can you repeat your question, please?
I have a very big problem in finding the uniform minimum variance and was just from the complete statistics. Can
Oh,
you?
okay, I will explain, but that is a very huge portion, na? So how can I explain in this class? I can explain you personally that the concept. How can you find? You want to know how we can find or the concept?
First of all, we find the complete unbiased estimator and the complete statement. After that, we find the uniform minimum variance.
So that
Unbiased.
I have taken class about this. Na, you can see the video on that. Because this is not the time for give you that definitions, right? Can you please see the previous videos on the drive? I taken class about. Na, Sai, can I take? Have I take the class about UMVV or completeness? I think I have
Yeah,
taken.
yes, you have. You have.
Yeah. And there is a good note about this thing. How can you find the concept, all the thing? But on that class, I cannot came to that minimal sufficient, not that ancillarity. So that's why I'm coming here.
Okay.
Uniform theta, yeah. Uniform theta plus one, theta two. No, that doesn't have UMV because theta one, theta two as a x order one, x order. How can you achieve UMV? So,
So any distribution that has two parameter sufficient statistic
hmm.
doesn't have UMPV.
No, this is actually uniform theta plus k1. That means theta plus some constant, right?
Like theta, let's say theta plus two and
No. That doesn't achieve UMV because theta plus one, theta two only gives you the statistic x order one, x order n. That is a two-dimensional statistic. That is not complete basically. And if you don't get completeness, then how can you achieve the an UMV?
Okay, so if we have distribution which is based on one parameter, but it has a two parameter minimum sufficient statistic,
Huh. No,
then
dimension minimal. Yeah.
then,
Continue.
then the distribution doesn't have UMV for the parameter, right? Is it
Yeah.
like that? Because this thing happens in curved exponential family too, I guess, theta and theta square, like normal theta, theta square.
Normal theta square. That is summation xi square, and that not complete because if you take minus on the those side, you can get zero, but that is not identically zero, right?
Hmm.
Huh.
Yeah.
But there is a good example where
So something
yeah,
means xi minus theta if we do that scaling and centering.
xi minus theta here. Okay. Yeah. Then
First to achieve the UMV, you know.
Uh, so here xi minus theta, how can you find UMPV here? So you have to come over this thing now. So there you can get x order one, x order is minimal sufficient, not the complete sufficient statistic.
We we can do it by
No, see one example. I am giving you example. Uniform minus theta. For this thing you can get the complete sufficient statistic. Okay. Or the example xi uniform minus I theta minus 1 I theta plus 1. For this thing also where you get the symmetry you can get that thing because you have to find the main concept. You don't understand all the thing. The main concept is that if the parametric space is one dimensional, then the complete statistic should be one dimensional, and if you get complete statistic, then you can achieve UMPV because UMPV if exists, then it is unique and
Sir,
completeness.
I think, sir,
Hmm.
we have to find the value of sorry, the
The
uniform theta one comma theta two.
once again,
Then if x follow
theta
uniform
1
theta one comma theta two, yes,
that x order 1 and x order n is complete statistic for theta 1 and theta
yes,
2 because
yes.
they are
Then
two parameter.
oh
Hmm.
sorry. Then the UMV
Yeah,
of theta one we can say that a in order x one with minus x in order divided by n and
yeah, right. No, you don't get my point. It just what I'm saying, just listen carefully. I'm saying what is the dimension of the parametric space. If it is theta 1 theta 2 theta 1 not equal to theta 2 theta 1 theta 2 is another thing, then this is a two parametric space, then the complete sufficient statistic is x order 1 x order n. Okay, so it is on not on your level, but I am giving you this idea because to when you see the question you can easily get that thing. Yeah, bhaiya said that thing that it is a one dimensional, but I get a statistic that is two dimensional, so complete statistic doesn't exist. This type of thing I am saying, I am writing here also. I write this concept here. So If, see, for these two things, complete exists. Like, now here you can see that what is the parameter involved in here? Theta, only theta. Theta belongs to omega. That omega belongs to real space. Omega subset of the real space. Right? It is the conceptual thing. Real space mean here it is a one-dimensional thing. It's a real line. But if it is given xi IID uniform theta 1, theta 2, then there are two parameter. Then it is theta curl, which is a vector, theta 1, theta 2, 2 cross 1. It is two-dimensional. Have you got idea, everyone? That idea they I'm writing. If parametric space is k-dimensional, then complete statistic, if exist, will be also k-dimensional. Understood, everyone, the concept? Yeah. Sign, understood?
Yes.
Yeah. Because it's very important. So, and what I'm saying there, x order 1 and x order n is minimal sufficient for that question. Now, can you say about me? That is, I am taking this question outside. Acha. Can anyone give me a immediate answer? That is, like x order 1 minus, no. Uh, I am making the question spicy. That's why you can not understand. So you know about the range. What is the formula of range? X order n minus x order 1, right? And and then x order n plus x order 1. These two things. So now can you say x order n minus x order 1 comma x order n plus x order 1? Is it minimal sufficient? Anyone? Is it minimal sufficient? Yes.
Yes, Bhaiya.
Why?
Because it is independent of the parameter.
No, it's a minimal sufficient. Yeah, one function, right? Why independent of it? That's the concept of ancillarity. Minimal sufficient, right? So it's minimal sufficient because it's a one function, right? Sign one function of x order. Good. X order 1, x order 1. Good. So right. So can you see that? Can you observe? What is this thing? Can anyone see? What is x order n minus x order 1? See, from xi, this thing I can achieve xi minus theta uniform 0, 1. Right? Now, x order n minus theta, it is beta first kind n1. And x order 1 minus theta is beta first kind 1n. Right? So x order n minus x order 1, whatever will be the distribution, yes, ancillary statistics, right, Ondrila? Right, right, you are. So it's a ancillary statistic. But how it is possible? That is, ancillary statistic is the garbage information, and we are also saying that minimal sufficient contain 100% information about the theta. So and it's minimal sufficient. So how a ancillary statistic content in it, right? So you know that x order n minus x order 1 is ancillary, and x order n plus x order 1 means nothing, na. Only x order n plus x order 1 is not complete, not sufficient, right? Everyone agree with me? Yes. So you can easily see that in a sufficient statistic, there is a involvement of the ancillarity. That means the garbage information, right? And also the thing is that x order n plus x order s is not complete, right? So that's why this thing happen, and we cannot achieve the completeness from this thing because the parameter is one. So complete statistic if exists, it will be one dimensional, and it cannot exist here because you can see that the ancillary statistic we are writing in that side, it is into the minimal sufficient statistic, right? So if we achieve a complete statistic, then it should be one dimensional, then this ancillarity will be thrown out from the statistic. So our work is to thrown out this statistic from the minimal sufficient statistic, then this thing come to be complete. Understood the spiritual idea about the completeness, why we do the completeness? Our target is to clear this ancillarity from that minimal sufficient statistic, then it come to the completeness. But the problem is that our parametric space is restricted to the one dimensional space. So so that's why it's an invalid argument for the completeness, because you are you are running through a parametric space which is a real line, but you want to get a estimate which will be a two-dimensional. It's a very illogical thing for the completeness, right? That's why this garbage information we cannot remove from the from the statistic. So that's why ancillarity. So the main argument is that if it came to your knowledge, or if it is like this type of question is happen, like the I am writing ancillary statistic or ancillary information may contain into the sufficient statistic, minimal sufficient, because it's a bigger class, I will not take that thing. Minimal sufficient, so minimal sufficient mean also implies sufficient, right? Right, it's an implication. And now Basus theorem, I said over this thing, I said over this thing.
So minimal sufficient and sufficient is same.
Yeah, please once again.
Minimal sufficient is same as the sufficient statistics.
Yeah, is a minimal sufficient obviously the sufficient statistic. The
Okay.
first thing is sufficiency, then it comes the minimal sufficiency, right?
Okay. Okay.
Yeah. So, my work is done. Acha, what I want to say, first order is done, ancillary is done, Basus theorem is done, and okay. So, mm, wait, just a minute. Yeah, I
Sir,
am getting. Yeah, Anubhav.
sir, xi following uniform minus theta theta, it will
Yeah,
not have the complete statistics as x1 and xn. How is it complete?
is it? It is complete. I am showing you. Uniform minus theta theta, right? So if you take modulus in that side, it will be uniform 0 theta. So it's maximum. So the sufficient statistic for the complete statistic for theta will be maximum mod xi, because you know x order n is the complete statistic, right? Understood?
Yes, sir. Yes.
Yeah. Hmm. Okay, I am giving you some question. That's a very important type thing. Okay, so can you say me Acha, one more thing I want to say to you, that is, acha, can everyone know that? Acha, all of you know that the one function of sufficient statistic is sufficient. Can all of you know the every function of a complete statistic is complete? Anyone know about this thing? If don't know, I will give that, write that statement, or can I give some justification also? Everyone, yes or no?
I only the every function of the completeness is a complete statistic is uniform minimum variance for adjustment only.
No, that's the wrong idea. Don't know, Vanishka. Yes, but I don't know the proof. Yeah. Okay, I am going to the proof. So it's an interesting proof. Only bijective function. No, eight. Okay. Or you have a confusion. Okay, I am giving you this idea. This can okay, actually this type of confusion I also faced when I taking the preparations or in the bachelors. So that's why I want that type of things should clear on your mind. So see, the statement, it's a statement. Every function of a every function of a complete statistic is complete. So you can prove this easily. Like take a statistic t, right? So I am thinking that x1 up to xn is a random sample, is a common random sample from some, that distribution, the family, from some family of distribution, like f theta x, theta belongs to the parametric space, and then suppose t equal to hx curl be the, not only that t is the tx curl is the complete statistic for theta, right? Now what you have to show, every time when you see the statement, you have to think that how can you go to approach this problem. So every function of a complete statistic, so complete statistic is t, I am assuming. So every function, I am taking a function, any function, if it is a bijective one, it's a many to one from many to one, any function, we'll work on this. So now I am taking a function, like if I have to prove that tx is complete, then expectation h tx curl equal to 0, I have to show that to tx is complete, that is I have to show a function of the tx is complete. So I'm taking a function, let u is equal to ht is any function of, right? So then I have to prove that u is complete. So expectation ku equal to 0, but we have to show this thing imply k equal to 0. Now expectation ku equal to 0 imply expectation k of ht, yeah, ht equal to 0. Now you can see that it's a composition of function k composition ht equal to 0. Now I am taking this composition at psi, then it is basically expectation psi t equal to 0. Now you get the idea, right? That is a function of t. So you know that t is complete statistic, for theta. So expectation sin t, any function of t equal to 0 will imply sin t equal to 0 with probability 1. Yeah. So probability sin t equal to 0 equal to 1. Right? So sin t equal to 0 means sin sin t is, oh wait, I am doing any mistake here. KHTX curl. So sin t, yeah, no, not mistake. So sin t equal to 0 means KHT equal to 0 with probability 1, and KHT equal to means KU equal to 0 with probability 1. So obviously expected value Ku equal to 0 imply Ku equal to 0 with probability 1 means U is a complete statistic. Understood everyone? Got it? The idea? Okay. Everyone got it, the idea now? The what is the, and this statement is very important. Okay, every function of a complete statistic is complete, right? Okay, now yeah. The next thing is that I am giving you a problem that will be like of the last problem today. That is is a using of the Basu's theorem. The problem is that xi IID uniform 0 theta, theta greater than 0, show that can anyone show me this thing? So I'm not going to the proof. You all know that x order n is complete sufficient, right? Now you can observe that x order 1 by theta is beta first kind 1n, and x order n by theta beta first kind n1, right? Now if I take it x order 1 by theta by x order n by theta, the distribution, whatever be the distribution, will be independent of theta. Acha. So that's it. X order 1 by x order n is ancillary. So that's why x order 1 by x order n and x order n are independent. Now can you prove it? It is the spiritual proof. Can you prove it by distribution sense? Acha, can anyone know the immediate result of x order 1 by x order n? Anyone have any idea? X order n, so we know that is beta, beta first kind n1 x order n by theta. But can anyone idea about this? I am giving you the distribution. The distribution will be like beta first kind 1 comma n minus 1. Right, it is a very important and very new thing to you, right thing. So you just remember this thing. I am proof also. I am giving the proof also. So have anyone know this formula, this transformation?
No.
Okay, so right, I'm giving you this idea. This is a very this is very important. Okay, now I'm giving you the idea how to prove. For ISI that will be useful, for jam purpose that's okay. Okay, so by Basu's theorem you just say the thing, but spiritually the thing is okay, but how can I prove is by hand? So just find fx order 1 x order n, right? So that fx order 1 fx order n xy will be n factorial by 0 factorial, n minus 2 factorial, 0 factorial, fx to the power 0, fy minus fx whole to the power n minus 2, 1 minus fy to the power 0, fx, fy, x less than y less than theta 0. Then it is n into n minus 1, n minus 2 factorial. So n into n minus 1, y minus x by theta whole to the power n minus 2 into 1 by theta square. Right. So that thing will turns out n into n minus 1, y minus x to the power n minus 2, 1 by 3 to the power n, right? Now take z equal to x order 1 by x order n and t is equal to x order n. So this thing will turn out like give x order 1 p by t, right? So small p is equal to tz and what I am giving you that thing, t is equal to x order n. I am giving this name by k, right? So k is equal to t, right? Okay, so p matlab x order 1 and the k is x order n. So p is tz. Oh, that is k. Wait, I am writing something wrong. Oh, this is kz, sorry. This is kz and then k is t, so it is tz, right? So what will be the Jacobian? The Jacobian will be old by new. So what is old here? The old is x order 1, x order n. So del p by del t, that is z, del p by del z t, this one, this 0, I guess. Am I do right thing? Just let me see. Del p del t, del p del z first. Because I am doing over del x by del y, na? So del p del z first, I guess. Same thing actually. Del p del z and del p del t, there's 0, this thing, right? So it will be t. So the mod j will be t, then f of z comma t, small z comma small t, that will be turn out to the n into n minus 1. Oh, sorry. It's y and x I denoting na here. Sorry. This type of silly mistake I always do. Okay, so that's why I'm thinking, where is the x and y? So x equal to y z and y equal to t, right? So x equal to tz. So the del x by del z will be t, del x by del t will be z, del y by del z 0, del y by del t 1. That's it. Now n into n minus 1, y minus x. So y is t minus tz whole to the power n by n minus 2, 1 by theta to the power n, and the Jacobian is t. So n into n minus 1, n into n minus 1, 1 by theta to the power n, t to the power n minus 1, 1 minus z to the power n minus 2. Right. Now t running from 0 to 1, z running from 0 to 1. So from here you can observe that n t n minus 1 by theta to the power n, that is what? That is the x order n by x order n. Now x order n, what will be the x order n? The z is x order n. See, the t is x order n. So what will be ftt? Ftt will be n into capital Fx whole to the power n minus 1 into small fx, where t 0 to theta. So n t to the power n minus 1 by theta to the power n. Right. So you can see that n minus 1, 1 minus z whole to the power n minus 2. Got the idea? It is beta first kind 1 comma n minus 1. Got it? The idea, and they are independent. So you can also say that up to this understood now everyone? Hmm? Okay. Now also they are ancillary, that's why they're independent. Now the concept is that x order n is a complete and x order 1 by x order n is ancillary, so that's why they're independent. So by spiritual sense, by Basu's theorem, you can say the independence. By the distribution theory, you can say the independence. Got it everyone? Right? Okay. So do you have any doubt from today's class? Yeah, I cannot complete other things. You can see that I I gave 2 hours class. That's but till now I have some of your doubts that's are unsolved. But I will try to. I will say Srijit that to solve that doubts by other faculties also. So yeah, that's it. So any doubt from today's class? Do you enjoy the class? The first, the most thing is that is it helpful? That is the things are you don't know, you know about that things, right? Yeah. Sir, can you please send some notes on efficiency asymptotic? Huh? It's on my wait. It's on my website, I think. Hmm. Let me see. Just a second. I think I have written down that in my website. Hmm. No, 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 no. Okay, I will send that note. asymptotic efficiency. So yeah, that's 3 or 4 formulas. Like, so an efficiency and asymptotic efficiency is 3 or 4 formulas. Like, if you, that is basically efficiency. What is the efficiency? Efficiency is all about the precision of the statistic, right? So you just take the ratio of the statistic, this type of, I think 5 or 6 formula. Okay, I have written that thing, I will send you, and you just give me a reminder on WhatsApp, right? Okay, Shinjini. Okay, so okay, I will check. Okay, no, that's on, not on my website. Okay, I am, that's not on my website. I am just observing that. So but I don't get time to upload that thing on my website. So I will send you that on the group or personally, if you want. So just send on, just give me a reminder on the WhatsApp. So I will send you that thing, that note, right? So okay, that's it from today's class. See you on the next Sunday at 7 p.m. And all the best for your preparation, and do solve problem every day in a time, take a proper sleep. That's the advice from your bhaiya, right? Not from the points of teacher points of view, because I am also a student and I face that situation that you are now face. So it's all about 20 or 30 days before jam. So take a proper sleep, don't tension about it, because you working hard towards the year, so you obviously get the result. Okay, right? Okay, chalo, good night everyone. Bye. Okay.